Benedict's reagent is a chemical reagent named after American chemist Stanley Rochester Benedict. It is a complex mixture of sodium carbonate, sodium citrate, and copper 2 sulfate pentahydrate. This is the structure of citric acid. If you replace one hydrogen or one proton here by sodium plus, you will get monosodium citrate. And if you replace three hydrogens, this 1, 2 and 3, then you will get trisodium citrate. The principle of Benedict's test is that when reducing sugars are heated in the presence of an alkali, they are converted to powerful reducing species known as indiols. Indiols reduce the cupric compounds present in the Benedict's reagent to cuprous compounds, which are precipitated as insoluble red copper 1 oxide. So in case of Benedict's solution, Cu2 plus, which is a cupric complex, is present, and it reacts with the aldehyde group, and aldehyde or this keto group is converted and oxidized. Then we get oxidation products, and this copper 2 plus is reduced to copper 1 oxide. So in case of aldoses, if you take beta D glucopyranose, the open chain form of this D-glucose will react with the Benedict solution, and this CHO group will be oxidized into carboxylic acid group. As the medium is basic, this will remain as carboxylate ion, and you will get a gluconic acid salt. Now in case of alpha hydroxyketose, this is the structure of alpha hydroxyketose. What is the alpha hydroxy? The alpha hydroxy means this ketone, and this is the alpha carbon. The alpha carbon of this ketone contains an OH, an hydroxyl group. This is called alpha hydroxyketone. If you add Benedict solution, as it is basic, this alpha hydroxyketone will remain in the indiol intermediate form, and this will further react with the base to give aldehyde or an aldose. Now if you add the Benedict solution and or the copper 2 plus ion, then this aldehyde will be converted into carboxylate ion, and the copper 2 plus complex will be reduced to this Cu2O, copper 1 oxide. If you take beta D fructopyranose, then this is the chair form. In medium, this will remain in the equilibrium with the open chair form, and this open chair form will remain in the equilibrium with glucose and mannose. You all know that in the basic medium, glucose, fructose and mannose, they are interconvertible. Thus now if you add the Benedict solution, you will get this gluconic or mannonic acid salt and a brick red precipitate of copper 1 oxide. Preparation of Benedict's reagent. At first dissolve 173 g of sodium citrate and 100 g of anhydrous sodium carbonate in 800 ml of slightly warm distilled water. Filter it if necessary. Then dissolve 17.3 g of copper sulfate in 100 ml of distilled water separately. So in one pot you are doing this, in another pot you are doing this. Then you are adding these two mixtures. So mix this copper sulfate solution slowly with 800 ml solution mixture with constant stirring. Now make the final volume 1 liter, that means 1000 ml, with distilled water. Now this is an experiment if to understand whether you have an aldose or ketose. If you put the substance in water and then add 3 ml of Benedict solution, and you have to then boil for few minutes. If you observe that a red, green or yellow precipitate is appearing, then you have to be confirmed that the reducing sugar is present there. And if the solution remains clear or just a little blue color appears, then you have to be confirmed that reducing sugar is not present there. Benedict's reagent can be used to test for the presence of glucose in urine. Glucose in urine is called glucosuria and can be indicative of diabetes mellitus. But the test is not recommended for the diagnosis of diabetes mellitus, because in case of urine there are a number of other things are present in urine, so that's why it can give any false test. That means maybe glucose is not present, but still you are getting a positive test with the Benedict solution. That's why this method is not done in practice.